Here's the answer for the day 4 bell work. Question A, rewrite as a logarithmic equation. This is the reverse process of what we did in the day 3 bell work when we had logarithms to begin with and we thought of them in their exponential format. So we're going to write the word log. Now, which part of this exponential is the base? In this power, the base is 5. So that goes right here by the word log. Then the equals 125 becomes the argument of the log. Then equals, and now the exponent of 3. If you take a quick peek back at day 3, you'll notice that you had things that looked like this, and then we conceived of them like this in order to solve for x. Question B, evaluate on a calculator. Log base 10 of 25.4. We could try to do this mentally by asking 10 to what power makes 25.4, but that's not going to work out to a whole number answer. So we're going to have to use the calculator. So pull the calculator onto the screen. The log base 10 button is the button on the calculator that says log. So when you push that button, all it says is log on there. There's not a little 10 in the bottom corner, but that's automatically log base 10. And now type the 25.4. Close up the parenthesis around it and push enter. And we see that the answer, if you round it, is 1.40. Now question C. Find the domain, the vertical asymptote, and the x-intercept of this function. One option is to graph the function using the calculator, and then looking at the graph, you can find these 3 features. However, it would be better if you could figure out these 3 features from the equation so that when you then draw the graph, you're able to use these 3 things to help you draw the graph. So domain, what numbers are you allowed to use for x in a logarithm expression? X must be greater than 0. You cannot find the log of 0 or the log of a negative number. Because remember how you find a logarithm. In this particular expression, the base is 4. When evaluating a logarithm, you're looking for an exponent. You'd be saying like 4 to what exponent would make this answer here. So 4 to what exponent would make 0? That's never possible. Or 4 to what exponent makes a negative number? That's not possible. For that reason, the argument of a logarithm must be greater than 0. So if x has to be greater than 0, now we know where there would be a vertical asymptote line on a graph. There would be a vertical dashed line at x equals 0. It would trace right along the y-axis. Now the x-intercept. The x-intercept is what value of x makes the function turn out to be 0. So how could log base 4 of x turn out to equal 0? The base is 4. This number is the exponent, so think of it like this. 4 to the 0 power equals the x. So what's x? X is 1. So we figured out these 3 things without first graphing it, so that now when we graph it, we can use this to help us graph. Nothing in the question says to graph it, but let's take a look at the graph on the calculator anyway. So you push the y equals key, clear off that old one, and now we want to do the base 4 logarithm of x. So we can't push the log key that's on the calculator. That's base 10. We need a base 4 logarithm. So that's in the math menu. So you push math, and it's underneath the very first tab, math. It's not showing on the screen. We're going to have to scroll down until we get to the correct choice. There it is. You see that? Choice A there, log base. That's the one we want. So now it gives us the template. We can put a 4 in that spot, and then cursor over to the other position and put in the x. Then push graph. And it draws the graph. Now the graph looks like it starts right here at this dot on the y-axis at -1. It's almost like it kind of like has a dot and stops there. That's not really what it does. It goes along the y-axis as an asymptote line going downwards forever. Let me zoom in on that. You can see that a bit better. So zoom in is choice 2. The dot is blinking right at the origin. That's a good spot to zoom in at, so I'll push enter. Here we can more easily see that the x-intercept is right there at 1, and that the curve is coming down, 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 and looking like it's going alongside the y-axis.